Hey y'all, so we're going to go through the examples in our homework tonight, which is on mole ratios. I figured I'd put this video together just in case you need a little bit of extra help despite what we did in class today, all right? So here's our first reaction. The reaction actually happens when we have hydrogen gas. That's why it's H2. Remember, that's a diatomic, so it has to come in pairs when it's a gas. Okay, so hydrogen gas and oxygen gas, also a diatomic element, right? You add those together, you send some electricity through it, you send a spark through it, and it causes an interaction between the two that ends up forming water. Now, most of that's going to be water vapor, but it does very quickly cause a reaction to occur that gives us water. So the first thing that it wants to do, of course, is to balance the equation. So that's the first thing we'll do. So I look at the H. The H, it looks like I have two H's. Those look okay. And so I'll move on to the oxygen. I need two oxygens on this side, so I need two over there. I see that I only have one over here. And so I'm going to need to put a 2 in front of the H2O there. Now remember, when we're balancing, we only put the numbers in front. We don't change the chemical makeup of those elements. If you put a subscript, that actually changes what the chemical is. It could change it from water to hydrogen peroxide or something else, which we don't want to do. So we want to make sure that the numbers that we add are added in the front, saying that I have 2 water molecules, not changing the molecule itself. So I've got a 2 there. Now that does balance the oxygens. I've got 2 oxygens there, 2 oxygens here, but now I do have 2 H2s. So I have 4 hydrogens there, or 2 H2s. So again, I'm going to need to go back to the hydrogen and double check that. And so I'm going to put a 2 in front of that to say that I now have 4 hydrogens over here. So 2 H2s there, 2 H2s here. Now it's balanced. Okay. Now I am going to take that, I'm going to rewrite it over here, just because at some point I'm going to need to scroll this screen up, and I'm going to need to be able to see this. So there we go. All right, so we have balanced the equation. We're going to now scroll up to the next part of the question. And we're going to try to answer the rest of these given the information that we have here. Okay, so the first question then, aside from the balancing, is what is the H2 to H2O molar ratio? Now this part should be somewhat straightforward because all it is a fraction where we're going to put H2 on the top, and we're going to see how many moles of H2 we need from this reaction, which is 2. So if I use 2 moles of H2, and then how many moles of H2O, you can see right here you get 2 moles of H2O, right? And so that right there would be the molar ratio. Now this molar ratio, remember, can be used like that, or we can use the reciprocal, because if I get 2 moles of H2O, I must have used 2 moles of H2. So you can use it this way, you can use the reciprocal, either way is fine. Okay, we won't know what we need until we actually get to a point in the question where it's asking us for that. Okay, so the next step is, suppose you had 20 moles of H2 on hand and plenty of O2. So it's saying that because when we burn this is when we do this, we're saying we have lots and lots of oxygen. Maybe this is done in the air where there's plenty of oxygen around here in the room. And so if I were to put hydrogen in here and then send a spark through, I would get that reaction to happen. And I have plenty of oxygen, so the amount of oxygen is not important. What is important, what will limit my reaction, the limiting reagent, is the hydrogen. However much hydrogen I have, that is then going to react with all of the oxygen in the air to then give me whatever water I end up with based off of how much hydrogen I start with. So that's why it's saying I have plenty of O2. All right? How many moles of H2O could you make? So the question then is, how much water can I make from that? All right? So we're going to start, recognize that the question is saying I have H2 and I want to know how much H2O I have. So if I did not already have a mole ratio, I would make sure that I write a mole ratio for H2 and H2O. I do already have that right here. So I'm going to write down what I start with. I start with 20 moles of H2. and then I'm going to multiply it by the conversion fraction, right? Now that conversion fraction or that conversion factor needs to cancel out the H2. And so you see right here, I do have the mole ratio that has hydrogen and water in it, but I want to make sure to use this in a way that the H2 is going to cancel out. And so when I write this, I'm not going to put H2 over H2O, I'm going to do it the other way. When I do it the other way, when I put H2 on the bottom, the H2s will be able to cancel out. So I'm going to write this as 2 moles of H2 and 2 moles of H2O. From there, it's just doing the mathematics, right? So we're going to go ahead and cross out the H2s. Okay, those cancel out. And then I'll be left with 20 times 2 divided by 2. So 20 times 2 is 40, divided by 2 is 20. And so I end up getting 20, and the units that are left are moles of H2O. And we've managed to answer the question that they've asked. All right, let's try another one. Let's go on to the next one. Suppose you had 20 moles of O2. So this time, I'm starting with the O2. And enough H2, so we're saying for whatever reason, we've got plenty of hydrogen. So we're going to be limited by the oxygen. How many moles of H2O could you make? Okay, so this one's a little bit different. The last one started with H2 and ended with H2O. This one is saying I have a certain amount of O2. So I'm not going to be able to use this mole ratio. I'm going to have to write a new one. All right, so we're going to go into making a new mole ratio. So I'm going to look at the O2. The O2, it looks like I only need 1 mole of O2 here. So I'm going to say 1 mole of O2. And how does that compare to the H2O? It looks like right here I need 2 moles of the H2O. Okay? So 2 mole H2O. So that is the mole ratio that will allow me to convert from moles of oxygen to moles of water. Now remember that these are really saying I need 2 hydrogen molecules for 1 oxygen molecule to create 2 water molecules, right? We're balancing the actual number of atoms going into that. However, by scaling it up, the number of atoms that I need is going to be equivalent to the number of moles that I could use as well. Okay? So with this, I'm now going to write down that I'm starting with 20 moles of O2, and then I'm going to multiply that by my ratio. Now the ratio, again, notice that I've got O2 on the top. I really want to be able to cancel out the moles of O2, so I'm going to put the moles of O2 on the bottom. So otherwise exactly the same, but we are going to go 2 moles of H2O and 1 mole of O2. Now I did this first because that meant I just needed to think about which 2 elements I needed. Once I have that, I don't have to think about creating a new ratio. I just have to think about, do I want it this way or do I want it flipped? Okay, so if you'll follow this process, it will simplify looking at one thing at a time, but being able to create this process where we're doing several different things. Notice again, we are going to have the moles of O2 cancel out. And so therefore, I'm just going to have 20 times 2, which is 40. You can divide by the 1, but it's still 40. And so my final answer is going to be 40. The units are moles of H2O, just like what we wanted. All right? Now, if I'm not going to go into the advanced ones right now, I'm going to do them at the end of the video. So I'm going to skip that, okay? But we will come back to it, okay? So make sure you've got this written down because we are going to need this when we come back later, all right?